Hey guys, this is kind of the next big thing for us. It's a new integration technique, actually different from overall we learned is formulas like the integral of cosine is sine and the integral of x squared is x cubed over 3 and so on and so forth. So this is actually a new way to take integrals that we haven't seen before. So the best way to start talking about this is to remember the chain rule. And remember that when we take the derivative of a composite like this, the derivative of the outside, in this case it's cosine, you leave the x squared in there and you multiply it by its derivative. That's the chain. Derivative of negative cosine is sine, so we get sine of x cubed, and then that times the derivative of the inside, which is 3x squared. We're cooking with gas. Same kind of trick here. I'd rather not expand this fifth power, so I do like 5 times this thing to the fourth. I use the like power rule for derivatives and then times the derivative of the inside, which is 2x. This is how chain rule works, right? Right. So this is like a way to think about that. Instead of calling it G in here, or we could just call it U instead. And so basically we're saying if the thing inside f of x, if here we call it g of x, but if we called it u, which we could, then the derivative of f is f with respect to x of f of u is the derivative of f at u. Again, that's this part. F prime at g of x is just f prime at u times the derivative of u. So basically the derivative of sine u, this is like the same examples essentially, is the derivative of the outside cosine u times du dx or u prime, whatever you want to call it, because it's always a derivative of the inside. Same thing here. This is going to give you sine. Try that again. Give you sine of u times du dx. It's always the du dx is a chain rule every time. Same deal here. Up here, the u was x squared plus 9, so we left that in there to multiply by its derivative. Here we leave the u in there. So 4 multiplied by its derivative. Again, there's nothing different about the 3 examples on this page than there are on this page, except on this page I gave you functions inside the f, and then this one I just called it u. That's the same thing. The chain rule is applying every time. So this integration technique is called substitution or u substitution. It's called u substitution because we almost always use the letter u. You can use whatever letter you want, of course, but u is pretty common. So basically it says this. It says the integral of a composite function. This is like a composite function. It's like f of something, where the something inside is not just x. If you have that integral and then its derivative, and by it, let me say it again. Like the it that's important here is that I have u inside this function and I have u prime outside. When I say outside, I mean like not inside that function, but still inside the integral. Like remember, the integral starts with this symbol and ends with the dx. So basically the derivative of u is sitting somewhere inside the integral still. And if that works, then this is just the antiderivative of f evaluated at u. And it's like a change of variables thing. And the idea is that if you can rewrite this thing, you normally get an easier integral to evaluate. And this is so vitally important that I cannot overestimate it. If you choose the right u in these problems, they get very easy very quickly. If you don't, they get very difficult very quickly. So let me give you an example. I'm going to rewrite this a little because I don't like the way it's written and it's like not a picture I can edit. So we're going to say du dx here instead of u. So this is like not an integral that I have a formula for. I have an integral for sine. I have a formula for sine, and I have a formula for x cubed, and I have a formula for 3x squared. I don't have a formula for all of that stuff together. There's no product rule. I can't use that anymore. So here's what you notice, hopefully. You're like, this is a composite function right here. Sine of x cubed is a composite function. Where the inside function is x cubed and the outside function is sine, And hopefully you notice that the derivative of x cubed is 3x squared. Like the derivative of this inside function is sitting right here in my integral. The derivative of the inside is sitting right there. Derivative of this is 3x squared. That's kind of what I was trying to get at here when I was like, the derivative of this inside function should be sitting in the integral. I mean, it should like appear somewhere as part of the integrand. So here I'm like, the inside function is x cubed. The 3x squared is sitting somewhere inside that integral. And that means I can probably use substitution. And when it's set up like this, what I want to do is I want to choose this inside function here as u, whatever's inside the sign. So u is x cubed. Often we choose the inner function. Like when we think of, if we think of this sign of x cubed as f of g of x, we usually choose the inside function g as u. And now du dx is 3x squared. And so, I wish this was written better, it's kind of ugly that way. So, we're going to do the u's, it doesn't matter what color. Du dx is 3x squared. And now what you're going to do is you're going to quote unquote multiply by dx. Cross those off. You get du equals 3x squared dx. And this is why that's important. Because now I'm going to actually do the substitution. So I go down here to do my substitution. I say this is the integral now of, well, this sine of x cubed is now sine of u, because x cubed and u are the same thing. But still left over in there is a 3x squared and a dx. And this thing is really out of hand now because I can't have u's and x's in the same integral. That doesn't work. So maybe you noticed that this and this match perfectly. Right? If I want to get rid of this 3x squared dx, I have something I can substitute for it. I can substitute du for it. So this thing is really the integral of the sine of u du. And this integral, we know how to do. We have a formula for it. It's negative cosine of u plus c. And that's great, but in general, in these problems at the end, we put, since the problem was given to us in terms of x, we're going to return it to x. So instead of u, I'm going to write negative cosine of x cubed plus c. So this is how u substitution works. It works with composite functions, like we said before, where there's like a function inside another function here. It's kind of like, it's, if there was a chain rule for integrals, it's kind of this because it utilizes the chain rule. But like often you choose the inside function of your composite to be u. You find du dx and you kind of figure out what du is supposed to be, and that's part of the substitution. So we'll see that this happens in kind of more than one way. I'm gonna split this video now because it's gonna get kind of long. So I'm gonna do some more examples in the next one. See you soon.